Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve a 3D geometry problem. As per the problem, if straight lines L1, x equals 1 plus s, y equals negative 3 minus lambda s, z equals 1 plus lambda s, and L2, x equals t, y equals 1 plus 2t, z equals 2 minus 2t, with parameters s and t respectively are coplanar, then lambda is equal to, we are given four answer choices. We have to choose the correct answer choice. Let's start by analyzing the given information. We are given the equations of the two lines in parametric form. The first step is to change these equations of lines into Cartesian form, which is also called symmetric form. Let's start with line L1. The parametric equations are x equals 1 plus s, y equals negative 3 minus lambda s, and z equals 1 plus lambda s. We can write this equation in Cartesian form or symmetric form by isolating s from all three parametric equations. From the x equation, I get x minus 1 over 1 equals s. From the y equation, I get y plus 3 over negative lambda equals s. And from the z equation, I get z minus 1 over lambda equals s. So the equation of line L1 in Cartesian form or symmetric form is x minus 1 over 1 equals y plus 3 over negative lambda equals z minus 1 over lambda. Now we can do the same for line L2. We should change the parametric equations into symmetric form. We should isolate t from all three equations. Let's start with the x equation. In this x equation, t is already isolated, so we can write this x equation as x minus 0 over 1. Now we can isolate the t from the y equation. Next, the z equation. So the equation of line L2 in Cartesian or symmetric form is we have to find the value of lambda for which these two lines are coplanar. If two lines are parallel to each other, then they are coplanar. If two lines are parallel to each other, they are parallel to the same vector or vectors that are scalar multiples of each other, which also means that the two lines are parallel if they have the same direction vector or their direction vectors are scalar multiples of each other. Let's start by identifying the vectors to which these two lines are parallel. Line L1 is parallel to vector 1, negative lambda, lambda, the terms in the denominator of the Cartesian form or symmetric form. This can also be called the direction vector of line L1. For line L2, the vector to which that line is parallel is 1, 2, negative 2, the terms in the denominator of the fractions in the Cartesian form or symmetric form. These two vectors are scalar multiples of each other if their x, y, and z components have the same ratio. So 1 over 1 should be equal to negative lambda over 2, which should be equal to lambda over negative 2. We can use this equation to find the value of lambda. We can use the first two ratios to solve for lambda. I get 1 over 1 equals negative lambda over 2. 1 over 1 is equal to 1. We can cross multiply the 2 to the left side. Next, we can divide both sides by negative 1. I get lambda equals negative 2. We should check whether this value of lambda is valid by solving for lambda from the first and third ratios in the equation and see if we get the same value of lambda. I get 1 over 1 equals lambda over negative 2. 1 over 1 is equal to 1. We can cross multiply negative 2 to the left side. I get negative 2 equals lambda. I get the same value of lambda. That means the value of lambda for which these two lines are parallel or coplanar to each other is negative 2. So the answer should be option A. This should be the final answer for this problem. So these are the steps you have to keep in mind to solve this problem. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.